Alright, we're just ramping it up here. It's checking out solving multi-step equations, and you're going to see some of them represented with images like this, where you have these two groups, and inside them this thing is going to be an x, and this is going to be the 10-cent piece, right? In this case, we're adding all this up to 30 cents. So we're just going to work in cents here. I'm going to say we've got 2x plus 10 cents equals 30 cents. Now, one way to solve equations like this, and you notice I'm kind of setting it up intentionally with the bracket. One way to solve this is we could just divide everything by 2, right? And it works out nicely in this case, because if we were getting rid of the second one, if we were just talking about one of these, it'd be equal to 15 cents, right? It kind of rationally works with the picture. So we could express that mathematically as x plus 10 cents, which is just sort of 1 cup, equals 15 cents. And now we would just solve this like we've been solving all along. We'll take away our 10 cents. We've got 5 cents left. This makes nothing. So x equals 5 cents. Right? The paperclip is worth 5 cents in that diagram. So that's one way to solve these equations, and this is a distribution equation. The first thing we did is we divided by what I'm going to call the coefficient, which is the name for it. We divided by the 2, right? That was this step. Secondly, we solved for x. We got x by itself, right? Right here, we're getting rid of the 10. We're getting x by itself. That's our solving for x. Okay, so 2 steps on that first guy. And I say that because we're going to use different steps for this next equation here. This is a distribution problem. We've got a coefficient again. So we've got 3 brackets now. Instead of 3 cups, we have 3 brackets, which means we have 3 d's and we have 3 0.4s. So we're going to do some multiplication here. We're going to do some distribution. 3 times d plus 3 times 0.4. That's going to be, in effect, what we're going to end up doing. So we've got 3d, we've got 3 d's plus 1.2. And that's still equal to the negative 3.9. Now we can do our 2 steps to get that, to get the x by itself. So we're going to subtract 1.2. Nothing on that side. It makes 5.1 on this side. Now our 3, we have our d term by itself. The 3d is what we're calling our d term. And now we can divide by, oh sorry, this was, yeah, there we go, negative 5.1. Now we can divide by 3 to get d by itself, and d is equal to negative 1.7 in this case. So check that out, pause it, go back, look over it if you need to, but make sure you can notice here there's different steps. First we distributed. Instead of dividing by the 3, we did this step up here. This is that distribution step. So we have 3 times the d and 3 times the 4. We added those pieces together because they were added together in the bracket. So that was the distribution step first, and then we solved for x, which in this case looked like getting the x term by itself. Oops. That was this piece, the 3d. And then next we got x by itself. Those are our steps. If you're still kind of wondering how this is working, that's a 2-step equation. Once we did this, it's all new. It's all review from what you've already seen. Okay, I'm gonna skip this guy for now because some of us might be comfortable with those already. You'll see that at the end of the video if you want to take a look at that one. This mean daily temperature is a bit of a different gig going on here. When we see mean, we should be thinking average. So mean or an average would be the low, in this case we're going to talk about temperature, it'd be a low temperature plus a high temperature divided by 2, right? We've got these 2 temperatures we're working with. And we get some information in the question here. It tells us that the average is negative 13.2 degrees Celsius, and that equals a low of negative 18.1 plus a high, which we don't know, divided by 2. And now we've got an equation we can solve, right? Now in this case we're gonna get rid of that 2. We're dividing, so we're going to use an opposite operation, we'll multiply. So then we're talking about negative 26.4 degrees Celsius equals negative 18.1 degrees Celsius plus that H, that high temperature, which we don't know yet, which we're looking for. So we get rid of that on that side, plus 18.1 degrees Celsius on this side, and we get negative 8.3. And now H is by itself, So negative 8.3 degrees Celsius equals H. I'm going to write a sentence over here just to make sure we clarify the high temp is negative 8.3 degrees Celsius. So that's our answer. And I always suggest with a word problem, you go ahead and write it into a sentence, which forces you to think through it, forces you to rethink the context, and just make sure you actually answer the question. Make sure you actually feel good about the answer you've got. Another one, next one here, we've got a couple x terms now. We've got a couple brackets where we're going to do some distribution a few times. So I'm going to distribute the 4. We're also going to distribute the 2, but in this case it's actually a negative 2. That sign, that subtraction sign, we can treat like a negative and stick it on to our coefficients. So we've got 4x minus 12 when we do our multiplication, minus 2x, and we've got negative 2 times 1, so minus 2 equals negative 4.2. Don't forget about this guy here. A lot of us want to call that positive. That's our tendency. So now we've got another step we're going to do here. You might have seen this yesterday. Now we've got to collect some like terms. This piece and this piece go together, and then this piece and this piece go together. So we've got 2x's left over, 4 minus 2x, and then we've got negative 12, we could say plus negative 2, so minus 14. Right? We collected our x terms, we collected our numerical coefficients. That all still equals negative 4.2. Sorry, getting a little messy over there. And now we can solve just like we always have, right? I'm going to get x by itself, that's a 4.2, so it adds to 9.8. 2x equal to 9.8. Going to divide out that 2, and x is equal to 4.9. So maybe a new step here, we, whoops, let's go back to our red. We distributed. If you're asking yourself what just happened, here it is, we distributed. We collected what we call like terms, and then third we solved for x. So from here it's all familiar, right? And there it's all familiar, but this is the new step that we are seeing in this last equation. Sorry, last one on the set. So of course we'll come back here now because we skipped this guy. And I did want to just pick through it just to make sure we got a hold of this yesterday. What we're doing here is we're going to multiply by the lowest common multiple, which in this case would be 10. So because in effect we're trying to get rid of the denominators. So if we multiply both sides by 10 over 1, this actually reduces to 2x minus 1 over 1, right? And this will give us on the other side 30 over 2. So 2x minus 1 then is equal to 15, and now we've got an equation we can work with, right? Pause and check out those steps if you're not sure about what's going on there. But from here it's just like what we've been doing today. X minus 1 equals 7.5, add 1 to both sides, and in this case our x is equal to 8.5. Okay. So just make sure you understand what's going on in here. Take a look at that. Take a look at some examples in the text if you're not sure about it. And good luck, you guys. Thanks.